In discrete math, function composition is the pointwise application of function to the result of another one. For instance, if I have function f that takes value from set x and returns value from I, and I also have function g that takes value from I and returns value from z, and now I can do composition of these two, and it looks like this. So first we have g, then there is this circle, and then function f. And this g circle f basically means this. So f grabs some x and returns us some I, and then function g takes the I that f returned and turns it into z. So this composition is basically a function from x to z, right? Think of it this way. You grab some x and you first pass it into f. F does some computing and passes the result into g. And finally, g returns us the final result. But it is not so easy. There can be problem. G must accept everything that f returns. So in this case it works because f returns some element from set I and g takes some element from set I. But you need to keep this in mind. So let's take a look at some examples. So I have here function f that takes some natural number and returns natural number, and it is defined as I is equal to x times 2. And then I have function g that takes some natural number and it returns us some integer number, and it is defined as I is equal to x minus 2. So let's see how composition of these two looks like. So for example, when I call this with free, I will pass free to f. F will return 3 times 2 because I is x times 2, so that is 6. And then I pass this 6 into g, and what g does? Well, it just subtracts 2 from the value that you have passed. So the final result will be 4. Let's try it again with 5. I pass 5 into f. F will return 10. Then g takes whatever f returned, in this case it is 10, subtract 2 from it, and return the final result. In this case, 8. I hope this makes sense. Let's take a look at another example. In here, I got f that takes some natural number and returns us some rational number. And it is defined as I is equal to 2 divided by x. Then I have function g that takes some natural number and returns us other natural number, and it is defined as I is equal to 2 times x minus 1. And I want to do composition of these two. So let's try the same thing. Let's call this composition with 1. So I grab 1, pass it into f. F returns us 2 divided by 1, and that is just 2, right? So g grabs this number and returns us 2 times 2 minus 1, and that is 3. And that is the final result. But maybe try this with 3. We pass 3 into f. F returns us 2/3, but here comes the problem. G accepts only natural numbers, and as you should already know, 2/3 is not a natural number. It is rational number. So that is why you cannot compose these two functions, because G cannot handle 2/3 as a input. I hope this makes sense, and I think it does. So that is pretty much it for this lecture. If you have any questions, feel free to ask, and I will see you next time.